guys, let's talk about the derivative of constant values. So if I showed you this equation and I asked you to take the derivative of it, you might start panicking at first, right? There's a lot of things going on. It looks like it might be messy. There's some trigonometry. But if you just take a deep breath and you break it down piece by piece, you'll realize a trick. Each one of these terms is actually a constant. Remember, constants are just values, they don't change, it's just a number, like 12, right? So our first one's pretty obvious, that's 12, so we know that's a constant. So we'll say C. E to the second. Remember, E is a number, right? It's like 2.7 something approximately. So E squared, that's just a number, so that's a constant also. Pi, 3.14 to the fifth power, that's just a constant. Sine of 2. If you plug that into your calculator, you'll get some weird decimal, right? But it's still just a number, so that's a constant. Same with cosine 3 pi. It's just a number. It's all constant. So what does that mean? Well, that means that the derivative is really easy to take because the derivative of any constant is always 0. So the derivative of all of this would be 0 plus 0 plus 0 minus 0 minus 0. So it's just 0, right? Let's talk a little bit about why it works out that way. If we think about the graph of a constant value, right? So say we have something like y equals 3, right? So let's say that here's 3, so we have this line, and this line is y equals 3, right? Well, remember what derivatives mean. They are the instantaneous rate of change, right? This is like the slope. And so for any point on this line, y equals 3, we don't have a slope, right? It would just be a slope of 0 because there's no going up, there's no going down, it's just a horizontal line. And so our derivative, if we were to take the derivative of y, it would be 0 because the slope is 0. All right, and you can apply this to any constant you see. If you're asked to take the derivative, you know the answer is just 0. I hope this helps.